Once again, the topic of this video will be the ultraviolet filter, focusing on the ballast. Look at this ballast is only 6 months old, but already looks like shit. Okay, look at this inductor. It had definitely seen better days. This is how a normal inductor should look like. There's also dark areas on the PCB, on the phenolic PCB. It's supposed to look like this, but instead, well, it's all burnt down. There's some skid marks on the enclosure as well. So yeah, and also this electronic ballast is producing awful noise, actually sending electrical noise back, which is worse because it can actually interfere on sensor readings and the control panel, so it has to go. Most electricians have a rule of thumb where they replace the ballast as soon as they replace the lamp, so they replace them at the same time because they're not reliable at all. And the worst about these ballasts is actually that they drive the filaments, the heating filaments at both ends. They are always driving them while the lamp is on. That's because they're designed to be a fast start solution, so they can degrade the lamp. The lifespan of the lamp is shorter this way. All summarized, I decided to go backwards. Got myself a big choke. This is actually an inductor. It's the electromagnetic ballast. It has two functions. The most important of them is actually it regulates the current that flows through the lamp while it's on, and it actually provides the high voltage spike that ionizes the gas inside of here at the start. So it actually starts the lamp and then regulates the current, because if this lamp actually has no regulation, it will actually blow up. And here's another important component: the starter. The starter will actually allow current to pass through the heating elements when it's trying to start the lamp. After the lamp is already on, it will actually interrupt the circuit to preserve the filaments and will keep the lamp running. This guy is not as reliable as the ballast itself, but it's actually it will be pretty reliable in the system because I only have to start this lamp a few times. Actually, it's a lamp that's gonna be kept running. That's the principle of ultraviolet filtration. So there's no downside in doing this. You guys can say that this ballast can actually produce and will produce harmonics. That's true, but nothing that a filter won't prevent. So just have to add a suppressor filter. So let's get started. Let's replace this piece of smelling shit. Let's go over the connections here and we'll give it a try. So that's the live connection. It goes through the choke, ends up here on this leg. The neutral comes here and actually ends on this other leg here. So the opposite legs on both sides of the lamp will go in series with the starter. So the choke is in series with the first heater, then in series with the starter, in series again with the other heater, heating element, and back to neutral. So at the beginning the starter is a dead short, so current will lighten up both heaters. They'll start to heat up the lamp. After a while the starter will interrupt the current giving a high voltage kick from the ballast and strike the lamp, like I'm going to demonstrate now. You can see the starter and the lamp's already on. I know that's not the proper way to do it, but well, it was hard enough to find those guys. When I find the socket here, I'll be replacing it. But for now, I'm just gonna solder those guys. And there we go. A quick fix for a terrible problem.